A couple of requests come up for synthetic division. It's probably one of the more different patterns, different skills that you'll see, especially if you've pretty much been following along with all the other ones. This is really different from anything that you've probably seen before. Um, I think I'm going to show you real quick how to divide with regular long division a polynomial, and then I'm going to show you the same problem with synthetic division and show you how much easier it is with synthetic division. So basically set it up like a long division problem. This is going to seem strange to you if you've never seen it before, but just go ahead and do your 8x squared plus 3x minus 26. Okay, so this is interesting. You're basically asking yourself, how many times will x go into 8x squared? Well, it would go in, if you did 8x squared divided by x, then you would just get 8x. So you go ahead and put 8x right there. And then you multiply this times this. So 8x squared plus, that would be actually a 16x. So I started to write 2x, but it'd be 16x, just like that. So then you would subtract, just like you do in regular division. So 8x squared minus 8x squared, it cancels. 3x minus 16x would be negative 13x. And then you bring down the negative 26. And then you have to ask yourself, how many times does x go into negative 13x? So you do negative 13x divided by x. So all you have is a negative 13, right? So you just do that, and then you multiply this times this. So negative 13x, negative 13 times positive 2 is negative 26. So all that cancels. So there's no remainder. So it goes in evenly 8x plus 8x minus 13 times. Okay, that would be the answer for right here. But I want to show you there's a little bit easier of a way, and it's called synthetic division. So I'm going to redo this problem with synthetic division. Check this out and see if you see how this works. Okay, so you set it up kind of differently. Instead of the regular division, you kind of do this little bracket thing. And then you get the coefficients. 8, skip the variable, 3, and then sign is negative 26. So basically this polynomial, just reduce it down to coefficients. Then you take the 2, like that. Okay, this is where it gets weird. You always put a 0 here, and you always do 8 minus this, which always is this thing right here. So that's the same pattern every time. Then you do 2 times 8, that's 16, and then you do 3 minus 16, makes negative 13. Then you do 2 times negative 13 is negative 26, and since these two things are equal, it goes in evenly. Now this is the weird thing. So this was my x squared row, because that went to 8x squared. Well, this is going to be my x row. So this is going to go to 8x minus 13. Okay, so it's super different, but that is the way that it works. Okay, let me do another one with just pure synthetic division so that you can see how this works. Okay, so you draw your little bar. X squared is just 1. Then you do a negative 4. Then you do negative 20. Then you do a negative 5 on the outside. You always put a 0 right here. You always bring this number down here. You always multiply this times this. So that would be negative 5. Now here's where it gets a little tricky. Some people don't know their negatives too well, but negative 4 minus negative 5 is actually positive 1. And then you would do negative 5 times positive 1. That would be negative 5. And if you subtract that, negative 20 minus negative 5 is actually negative 15. Okay, so that's going to make the answer be, since this was my x squared row right here, that means this is x plus 1, and then there's a remainder of negative 15 over x minus 5. Okay, so let's try that. Let's do x plus 1 with a remainder of negative 15. Okay, so x plus 1 minus, because it was negative, so I can just save myself some steps, and that should work. Okay, I know this is so different, so weird. See if you catch on if I do it again with you. Okay, so you're going to do a negative 3 on the outside for the x minus 3 right here. Then you're going to steal these coefficients. So you got x cubed is just 1, and then a negative 7, and then a 14, and then a 28. Okay, you always put a 0 here. You always bring this number down. You always multiply this times this. So negative 3 times 1 is negative 3. You always subtract. So you do negative 7 minus negative 3 is negative 4. You always multiply. Negative 3 times negative 4 is 12. You always subtract. It's 2. Negative 3 times 2, negative 6. 28 minus negative 6 is actually 34. So this was the x cubed row. That means this is the x squared row. So that makes this x squared minus 4x plus 2 plus 34 over x minus 3. Okay, so let me see if I remember that. X squared minus 4x plus 2. Okay, x squared, and then was it a minus 4x plus 2 plus 34 over x minus 3? Unless I switch to negative, it's hard to remember my answer, but okay, I did remember it. Okay, so I'm going to work one with you one more time. So the negative 3 would go on the outside. 1 for x cubed, negative 10 for x squared, 19 for x, and a 6 at the end. 0 goes there. You always bring this down. You always multiply. Negative 3 times negative 1 is negative 3. Negative 10, take away negative 3 is negative 7. Negative 3 times negative 7 is 21. Take that away, and that's 6, and that's 0. So there's no remainder. And this was the x cubed row. That means this is the x squared row. So that's x squared minus 7x minus 2. X squared minus 7x minus 2. Let's try that. X squared minus 7x minus 2. And I'm good to go. Okay? So these are challenging. They're different. I'm more than willing to help you if you need me to.